And on then to example 6, using sums of random variables. This is the example on depression in children. So here we're looking at a measurement of depression in children. A reduction in average CDI score indicates a beneficial effect. We have a study which assessed clinical referrals for depression with a mean of 11.2 and a standard deviation of 6.8. This was a group of depressed children, whereas the scores for a large group of normal public school children had a mean of 8.5 and a standard deviation of 7.8. So if we assume they're the not depressed ones, and if we assume normal distributions, what we're considering here is the probability that a randomly chosen depressed child actually produces a lower CDI score than a randomly chosen not depressed child. Now, in order to do this problem, of course, what we're looking for is, let's begin by saying, let D be the score for a depressed child and N be the score for a non-depressed child. So we're looking here for the probability that the depressed child score, the probability that D is less than N, the probability that the depressed score is less than the non-depressed score. Or if we write that down, the probability that D is less than N, that's the same as saying the probability that D minus N is bigger than 0. Because if D is less than N, it means that N minus D must be bigger than 0, not D minus N bigger than 0. Very important here that we get that the right way round. If D is smaller than N, then N is bigger than D, and so we're going to write here the probability that N minus D is bigger than 0. That's what we're considering in order to calculate this probability. So we want the probability that N minus D is bigger than 0. So in order to be able to calculate this probability, we need to be able to find the difference in the random variables N and D. So we're going to use the formula here for the expected value and variance of the difference in two random variables. So remember the formulas that we're using here. The expected value of x minus y is equal to the expected value of x minus the expected value of y. And the variance of x minus y is equal to the variance of x plus the variance of y. And those are using the general formulas for expected value of ax plus by. But importantly, because we're often using the difference in random variables, important to remember that the variance of x minus y is the sum of the two variances, not the difference. So here, if we write down the parameters for D and N, we had here the depressed children had a mean value of 11.2, so the expected value of D is 11.2. The standard deviation for the depressed children is 6.8. And the non-depressed children, we have the expected value of N equals 8.5, and the standard deviation of N, which is 7.8. So we're considering here the random variable N minus D. So the expected value for that, we'll call it x equals N minus D. So our expected value of x will be the expected value of N minus D, which is equal to the expected value of N minus the expected value of D. And those values are 8.5, take away 11.2, and that gives us negative 2.7. Again now, to find the variance of x, we need to find the variance of N plus the variance of D. So the variance of x is equal to the variance of N minus D, which is the variance of N plus the variance of D. And those values are 6.8 squared, remember standard deviation squared for variance, and 7.8 squared. So when we find that variance total there, that gives us 107.08, And so the standard deviation of x is the square root of 107.08, and that comes out to be 10.35 to 2 decimal places. So now we're looking for the probability that n minus d is bigger than 0 in our probability distribution for x. So we want the probability that n minus d is bigger than 0 is now going to be the probability that x is bigger than 0, where x is a random variable, which is normal random variable, with a mean of minus 2.7 and a standard deviation of 10.35. So again here, in order to calculate this probability, we could do a small sketch which shows us we have a distribution with a mean of negative 2.7, and we want the probability that x is bigger than 0. So 0 is on the right-hand side of the minus 2.7, and we want the probability that x is bigger than 0, so that right-hand side probability. So we can calculate that as 1 minus the probability that x is less than 0, and that is 1 minus the norm dist function in Excel using 0 for x, minus 2.7 for the normal, mean of the normal, 10.35 for the standard deviation, and 1 for cumulative. And that probability comes out to be 0.397. And we can find that norm dist function in Excel. Again, using Excel here, we have norm dist, and we're using 0 for x. We have minus 2.7 for the mean. We have 10.35 to 2 decimal places for the standard deviation, 1 for cumulative, and that comes out to be 0.603. Remember, we were using 1 minus that value, and so 1 minus 0.603 gives 0.397. And that's the end of example 6.